And thanks for coming to my session. This is a topic and a technology that I'm really passionate about. I love playing with. I'm a network guy. When I go into my security groups, talks, the hacking groups in the metropolitan area, it's like, hi, I'm Jeff. I'm a network guy. How many network people in the room? Generally, no hands, right? That's okay. But this is even a more kind of a fun combination. Out on my GitHub site, GitHub Jeff Carrell, there's another directory. It's not for this specific presentation, but it is basically some just related info. Where do you get these tools I'm talking about? Where there's some other related information. There's an older version of this presentation. On the SharkFest website, they will have this version. So, but at the GitHub site, there's just some access to files. There's no hands-on kind of you do things, I do things specifically today because you got to build an environment. But even in this presentation, as you're going to see, if you put together a little bit of an environment like I'm talking about, I'd give you some of the things that you can do with some of these tools. All right, I'll give you a little Kickstarter. So information there, we're going to play with this. First off, who was in my V6 session yesterday? Hands up. Okay, hands down. Who knows V6 well enough that I say, what does an A flag do in the router advertisement? Who knows that answer? Wait a minute, you were in my session yesterday. We talked about this. There ain't no hands up. All right, well, this is okay because it's going to set where I'm going to have to start from. Last thing, who has ever successfully pinged between two devices on any V6 address? Wait a minute. Y'all aren't raising your hands the right way. All right? You got to know a little bit more than maybe you do. All right. So with this in mind, I forgot my point or my clicker. I want to do a little bit of V6 basics. All right. If you don't understand the basics of V6, how can you execute these security assessment tools? That is the layers 8, 9, and 10 polite way of saying V6 hacking tools. Right? Layers 8, 9, and 10 get a little weird. Thank you very much. Get a little bit weird when you use the words hacking and production network at the same time, right? They just don't like it. I don't understand what the big deal is, but nevertheless, they didn't ask Jeff. That's the pointer, and it's loading up. This is the nice one. Thanks, Saka. And it works. Okay. I love the green laser. All right. So humbly, you just need to know, right? And maybe some of this you know, some will try to go through this relatively quick. I'm backed up with lunch, so I have at least a whole nother hour. And if you get me started, I'll use it. Okay. 120-bit address in V6. All right. Big monster address. We use hexadecimal notation. I love to do my other little anecdotal note. Who remembers 20 plus years ago Apple Talk networking, Novell networking, all right? There's got to be at least one more old person in this room besides Jeff, right? Thanks. I've got my other token, old guy. 30 years ago, I remember talking about the old guys. And now, fast forward 30 years later, I'm the old guy category, right? So we've done this before, no big deal. We got it again. Life is great. Our 120-bit address block is broken up to 16-bit with a colon, another 16 bits. You have 8 of those groupings. Those groupings are called hextets. The next most favorite word is quibble. The next most favorite word, which is actually numerically correct, is hexadectet. I'm from Texas. That's a hard word to say. Even trying, right? It's got to have another syllable or two because I'm from the South. Anyway, hextet is the considered word, and it helps because we can relate that to octet in a V4 world. All right? You can do things nice and easy with your hex ones, like spell words in your addressing. It's cute, it's fun. Do it in lab, do not do it in production because you have just narrowed the attack vector for the bad guys infinitely smaller. Not just kind of, sort of. We're talking years worth of scanning savings. All right? Say again?
Facebook does it. Facebook does it.
Yeah, well, yes, and I actually have an example. Yeah, Facebook didn't listen to Jeff, and that's okay. They don't have to, right? In their 5th and 6th hextets, it's FACEBOOC. Facebook. Publicly out there, that's the way it is. All right? There's 32 bits of address part that I don't have to scan for because I know it. Right? So I've already got some of that figured out. So yeah, we got, and we were doing this, like I say, 30 years ago, Novell Networking, foosball, Dallas, dead beef, on and on and on and on, right? You can spell all kinds of fun stuff. 128 bits, everybody freaks out because they say, how in the world am I going to remember that number? All right, well, life is easy. The address is broken up basically into two pieces. 64-bit in the first half is your network prefix. The last 64-bit is your host ID. This is kind of a sort of period. 64 bits of host ID yields approximately 18 billion something addresses, and change. And everybody goes, I have 200 devices on my v4/24 network. Yeah? Who has a /23? Who's doing like 400, 500 devices on the network? You were there yesterday, weren't you? Yeah, I remember that hand. And yeah, so, thank you. Now I can take one IPv6 subnet and network the entire world in one layer 2 domain. Yeah, we're not going to do that either, all right? But it's these things to know, to start knowing that if my endpoint networks, my VLANs, all right, my individual routed networks in a /64, all right, I have 64 bits that I can scan for. The more or less timing is, today they still think it's like a 50-year to scan one subnet. We're not going to do it. And it doesn't matter if even somebody said, well, no, we're down to 10 years now. Who cares? All right, you're just not going to do it. So you have to get that part out of your mind if you're wanting to do scan of a subnet. Yes, sir. Bill.
You might consider that as the Internet of Things takes off, you may actually start needing most of those addresses.
Well, and that's one of the big things. Who knows or who realizes or who has heard or who cares? V6 has been publicly available to us for 20 years now, all right? And how much noise have you heard about it about every 5 or 6, 7 years? Oh, life is going to be bad until we get V6. We get V6, it has been a yawn for 20 years. There has been no driving force because everything that was in play when they first started working on the next generation protocol back in 92 when they kickstarted the project, they then in 94, 95 came up with our technologies of DHCP, NAT, RFC 1918. Those were stopgap measures to get us by till we came up with the next generation protocol. By the time V6 became released, first pass release, 99, we didn't need it. All the stopgap measures took care of the problem. If you remember IP networking in 92, everything was statically assigned with public addresses. We didn't have everything else that we do today. They were going to run out in that kind of thinking. Public internet was not up yet. All right, so everything that was driving things, they kind of foretold and knew that in the early 2000s they might run out of V4 addresses in that current state of operation. So there's a lot of things about V6 that have some inherent functionality. We're going to talk about those, and I'm going to frame these, and these are different attack vectors. Some are fun, that's not the right word. Some make it a little easier and some make it a little bit different, all right? Not necessarily make it harder. So this becomes one of the things we need to know. Can you take and say, 64 bits, I don't need anywhere near that many, and, have a higher network prefix and a smaller host ID area? And the answer is basically, no, you cannot. All right? It's not in the standard, and most server client operating systems won't even allow you. All right, routing operating systems may allow you. The last little tidbit on this is if you're doing point-to-point links, how many V6 addresses do you need? 2. You're going to use a 64-bit network to do that, and you're going to allocate it, but you're going to only use 2 addresses. And you can usually go ahead and define that as a /127. All right, most of the routing OSs support that now. The RFC defined it. That's about it. Are there client operating systems where you can bit fiddle? Yeah, maybe. Don't. Just don't. Things may not work. Not everything that you have up and running may work. You may get it working, but it's not going to fit a standard. An update to any software might change things, all right? So just don't even play with that. We have some shorthand notation. V6 fully extended. I could have zeros, leading zeros within a hextet, all zeros within hextet. The shorthand notation says I can concatenate down one or more hextet of zeros to a double colon, and I can drop all leading zeros. All right? The key thing is I can't do this. I can't say, well, I had 2 groupings of zeros and put in 2-bit two sets of double colons, because how many bits does each grouping represent? You cannot figure that out from that address. There's no way to know it. So you can't do it. I have yet to find an operating system that will even allow that to be configured, all right? So you can do like option 1, where I drop this down to a double colon, drop that 0, and drop each of these hextets first 3 zeros, all right, to generate the option 1. Similarly down with option 2. Any 3 of these is a correct representation of a V6 address. The standards say if you're going to use compression, and you should, compression and notation, you should do the one that gives you the most compression. Option 2 fits that, all right? But it doesn't matter if you do or don't, it will work. Upper lowercase in the alpha doesn't matter, but the standard says lower is the one to use. All those guys down Lower Bay here, about not quite an hour south on Tasman Drive, they don't listen to Jeff either. You'll put it in as lowercase, and they will convert it to uppercase. That would be Cisco if you hadn't caught on to all that stuff, right? All right. And that's okay. That's the way it is. Some environments, you'll put it in as shorthand, and they'll extend it always. Some will do upper. Some will do... Doesn't matter, okay? It will always work. This basic way, that one won't work. Can't be done. There's no broadcast traffic in V6. It's on-link multicast. And a really interesting tidbit to understand, when I say broadcast domain, I did not say broadcast traffic. Broadcast domain being basically your layer 2, your VLAN, okay? So there's a little bit of a differentiation for broadcast traffic. Well, broadcast traffic is on a layer 2 domain. In a V4 world, they're pretty much the same. We say broadcast, and we pretty much always mean the same thing, even though it's really 2 different. Not layer 3, but V6, you have to kind of really differentiate broadcast domain versus broadcast traffic. V6, it's all multicast. We've got 3 kinds of address notations in V6. Link local, global unicast, and unique local address. And the link local is like the V4 APIPA address, right? So on a V4 enabled interface, it comes alive. If it's not statically assigned, not DHCP, it comes up with the 169.254./16, all right? And you can run things on the network. Thank you, Microsoft, all right, for being able to do that local workgroup networking. And everybody else followed suit, and they made it an RFC. And everybody loves it. However, also remember, though, that a PIPA address in V4 goes away as soon as there's a real address, right? Either DHCP'd or statically assigned. In V6, the link local never goes away. The link local is required before anything else in V6 will work. And all on-link traffic is via the link local address. When you come to your router, you use the link local to the router. When you come to your neighbors, and now I have to say at a default level, your comm to your neighbors is on link local. Applications may use others, but just the generic V6 process uses link local. All right? So link local is going to be your first V6 address on an enabled interface. If it doesn't have link local, nothing else will work. You can't say, oh, I don't want the link local, I want just a global, which the global is referred to as an all routable, on-net or off-net routable. All right? You can't get that till a link local is there. That's just the way it is. All right? The unique local is likened to, but not exactly, but likened to RFC 1918. It's an on-net, local, routable in your domain, but not to the internet. If you force it out to the internet, the upstreams should be blocking it. All right? Similarly, in your routers or forward-facing firewalls, whichever is forward-facing, you should have ACLs to block the EULA address space. You shouldn't be getting it to begin with, but you got to protect yourself. All right? So the unique local gives that capability. There's a lot of entities that basically go, oh, I don't want this global, publicly routable address to be out on the internet. Well, then don't route it. All right? People who say that were not doing IPv4 back in the day, 30 plus years ago, right? 35 years ago, when everything was V4 public, whether you routed it out there or not. Now everybody thinks, oh, no. I want my RFC 1918 address, typically 10 dots, right, for bigger entities, and now I'm safe. And everybody should say NAT and safe should not ever be used in the same sentence, right? NAT and security are not words to be used in the same sentence. NAT is a slow me down, so says the bad guy, right? So we control things by real functionality. The linked local address is always prefixed, the first hextet, FE80::. It's provisioned as a slash, or it's blocked as a /10, but provisioned as a /64. FE80::, and 64 more bits, 4 more hextets. That is a reserved prefix, and that is the only way. I have not found any OSs, if they allow me to configure linked local by manual config, that will do it anything other than FE80. Okay, these are all standards, pretty well rock solid. The global unicast right now is from the 2000 through 3FFF. The only ones that have been allocated by IANA so far are only in the 2000s range. Now, if you remember any activity of V6 20 years ago, or see any documentation from 10 plus years ago, you'll see some references to 3FFE and the wording 6-bone. And that was basically the first part of the V6 backbone on the internet. About 10-ish years ago, I don't really remember, it doesn't, yeah. 10-ish years ago, they deprecated that, took it off the backbone and went to regular publics, gave it back to IANA, and so all of our so far allocated are 2,000 something. The unique local starts at an FC::, or FC00::7, but the whole FC range is completely reserved, so the addresses actually start with FD, something, something. All right, just as a point of reference. So I can do the unique local on my domain, route it any way I want, and if I need something to go out to the outside world, I need a global unicast. I could also have that on a client. So I've got a linked local, I've got a global, I've got a unique local, and that gives me at least a minimum of 3 different V6 addresses in 3 different networks, right? We will come back to some of that later. Just a quick bit on V6 multicast. So the on-links, the ones that we see the most of are going to be the FFO2::1::2 and ::1::2, basically for routers and DHCPv6 operations. So in the very beginning days of this whole next generation thing, the founding architects basically said, we want to be able to self-provision clients. We don't want to have to go manually configure the clients. You got to remember, 92, we didn't have DHCP. All right, it was all manually entered in. So they were trying to figure out a way, can you just turn it all on and things automatically happen? Sure, let's start with the MAC address of the network interface card. Oh wait, but that's 48 bits. I've got to figure out 64 bits for my host ID. There was an already existing IEEE standard called UE64. Takes that 48-bit address, chunks in FFE in the very middle, and ta-da, 64-bit address. I've got a host ID. Except IPv6 folks or IPNG folks said, you know, we want something that's even unique that we did it, not just a 48-bit to a 64-bit conversion process. So they said, fine. They took a bit that was unused, 7th bit of the first byte, you invert it, and now I have a unique address for V6 operations. Woohoo! One of my first thoughts about this whole process was, wait a minute, based on the MAC address, fine, I'll get this 64-bit number, strip out FFFE, uninvert the 7th bit. Now I know the MAC address. I go look the prefix up at the IEEE, find out it belongs to HP. Oh wait, go to HP site, find out those are laptops. Those are servers. You know, those are this, those are that, those are printers, whatever. And so by finding just a few addresses on a network, I could probably find what kind of network I'm on, right? This doesn't sound secure at all. And this was back later 90s as this was starting to come out and make sense. But it was all automagic. No human interruption. Nothing has to happen at this stage. So fast forward again about another 8-ish, 9-ish year, maybe even 10 years ago. And it kind of started with Microsoft. Said, you know, we need something a little bit better than this. Let's come up and do a random number generated 64-bit address. Yay! What's the great thing about random number generation? You have to start with something. You still have to have a start point. It's not specified in the standards what that is. The standard just says generate a number. One particular company, a few hours, well, probably more than a few hours, way north of here, near the Canadian border, all right, they start with the MAC address. And then they invoke a known hash algorithm that they publish. So they've slowed me down about 5 more seconds, right? Because I could write a script. That'll take me a long time. But I could write a script to figure all that out in reverse engineering and still figure out the MAC address, right? Because they gave it to me. Yay. But the second part of the standard said, not only are you going to generate a random number, you're going to generate a second one called the temporary address. And you will use the temporary address as your primary global address to communicate. And the other aspect of the temporary is it should change on a periodic basis. The standard doesn't say what that periodic basis is. So every vendor, even in different versions of their operating systems, do it differently, or can do it differently. Microsoft basically does the mode of, if I generate one, I'll put it in soft registry, 24 hours, I'll basically check to see if I can keep using it. And I'll do that for 7 days straight. As long as the interface is up, I may have the same temporary address for 7 days. And if you down interface, disable interface, unplug the interface, any of those things, everything starts over again. In Mac OS, now I don't know about the latest, but the few years ago's version, they regenerate every hour. So the best thing about this is you're running a client-server trace, and bang, 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 things are happening, life is good, and all of a sudden the address changed and nobody's screaming. You don't know that the address changed other than your packets stopped moving, right? Because there's nothing, that pair is no longer communicating. Nobody's complaining and the application's still up. They got a new V6 address. V6 has got a great thing about it that has 2 kinds of timers. V4 addresses have one kind of a lifetime. The valid lifetime timer is either set like hardware as infinite or through like DHCP with a timer. It has some sort of life in it. V6 has 2 timers, a preferred and a valid. The preferred says, keep rocking along, doing everything you're doing. At the end of the preferred, there's still some time left in the valid, and the valid says, finish up comms. We're going to get a new number for all new comms. So this is how things can keep working, and you can readdress behind. Things keep working, and you can readdress. You can dynamically readdress an entire network in the middle of the day, and nobody would know, and there would be no outage. But because how many people have ever readdressed a network? Come on, really? Who's addressed it? Or and did it work flawlessly the first time? Your bits did, right? Say again?
You didn't say that was a requirement.
I agreed, right? And we tested and we went through it and we went through everything we knew and it was going to work, right? And come day of doing it, you send out the email, everybody turn off your computers Friday afternoon, we're going to work on the network, come in Monday morning, everything comes up, most everything works except that hidden squirrel server that somebody's got in a closet they didn't tell anybody, and we didn't know about it. Now we don't even need to know about anybody doing anything because we can do it, and we're coming up to some of the other bits that allow me to do this. Everything about knowing about neighbors and what's kind of going on between each other in V4 is spread across multiple RFCs. In V6, it's all under the RFC that's basically titled Neighbor Discovered Protocols. So how I find out about things kind of at the underlying levels, I need Neighbor Discovered Protocol. I need to find out who my neighbors are. I need to find out who my router is, because now the router is a secondary and a very, very important thing. I can generate a link local address, but that doesn't get me off net, because link locals are not routable. It's kind of like period, all right? So I want to get off link. I need a router. Router will come online, and I can either query for a router can announce themselves, and then there's some bits, some flags that are set in this router advertisement, all right, that are going to help me along. There are 4 key messages in a V6 world under ICMPv6, all right? Router solicitations and advertisements, and neighbor solicitations and advertisements. If people are implementing V6 and on their firewalls they block a lot of ICMP parentheses V4 traffic, all right, and they say, we're going to mimic the policies in V6 just like V4, and they go block ICMP V6, things will come to a grinding halt. All right, you cannot block categorically all ICMP V6. We have to let some of it through. And if those folks are looking at it a little bit closer, they go, but that's going to leave us some security vulnerabilities. Why, yes, it will. All right, you have to know these things and work around them. So we're going to talk a little bit about this. Router solicitation is basically the mode of a node or a client, I'll leave it at that for the sake of ease, coming online and say, are there any routers on my network, any V6 routers on this net? All right, sends out this link local multicast to look at this. If there is a router out there, they will answer. So the router solicitation goes out. We'll see this kind of traffic, where we're destined to, what their source address, all right? Those are some things we're going to see here coming up, some things we're going to test against, all right? The router is out there, a V6-enabled router, and it's configured to send router advertisements, all right? Did you kind of catch on how I said that? And if it's configured, by default, if you enable a routing V6 interface, it will send out advertisements. You can stop that behavior. For instance, is you don't need router advertisements on a point-to-point link, right? You're not expecting clients. You may not need router or portions, now we have to say it this way, of router advertisements, say on your server networks. All right? We still need to have a router advertisement because I still need to know how to find my router, but I may not need things like DHCP support or a few other things. All right? So the use of the router advertisement is going to be the next piece of the auto magicness of how devices can get now the global addresses without any configuration, without DHCP v6. All right? Because in this router advertisement, I'm going to have some information that basically say, give me a network prefix, give me some valid timing, tell me how I should get my global unicast address. Do I use what the router tells me, or do I need to go ask a DHCP v6 server? The tick box in Microsoft, not to pick on, but just to kind of say, that says, you know, either use DHCP v6 or do a static, that tick box is not needed. Right? Humbly to me, it looks like they took the same front-end code of their v4, ported it to v6, and made it work. That tick box doesn't matter. Whether you give it a static address or you say dynamic, it doesn't matter because the protocol stack is going to use some of these flags in the router advertisement. All right, but it's still there, and most of the other OSs don't have that kind of a thing. We also have another flag in here that basically says, I am an on-link router to be used. I could have everything else going, basically be a supplier of info, but not your router. All right. So there's actually, out of the bunch of flags, there's 4 particular flags that are important in here. This is also what we're going to want to test with our assessment tools. So router advertisements occur in 2 modes, either by the router on a periodic basis, approximately every 6 to 10 minutes, or if the router first comes online, it sends out 3 router advertisements, bang, 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 to help anybody out that's on the network that's just been going, I'd love to go out, but I got no router. Hey, look, there's a router, cool. Well, and the router told me to do something. This is really important. You've got to remember that, hey, there's a router, it just told me something. All right? The router will respond to the router solicitation. So if a new node comes up, say at that 4-minute mark, all right, it's not going to wait 2 minutes to come on the network, right? That's just not going to happen. So a new V6 node coming online sends out a router solicitation. Anybody home? Anybody out there? And the router will answer immediately. So you'll see routers advertisements periodically on a V6 network if there's a V6 router there, all right? You should expect these things, all right? And most of the router V6 routing code will allow you to tune what that periodic basis is. You may want it more frequently, you may want it less frequently. Lab work, you actually want to turn these things down to really, really frequent because you're testing, you're working, you're playing. Production, you might even open it up depending on what's going on in your particular network. Maybe you don't need them that often because those who want an address are going to ask anyway if there's a router out there. So we're going to see this kind of traffic, and we expect to see it. Neighbor solicitations and neighbor advertisements are kind of done in just those modes. I need to find out. I'm going to build, quote, my ARP table. Now it's a V6 neighbor table, all right, but it's the same thing as a V4 ARP table. One of the things that happens in a V6 world, very similar to V4, as soon as an interface comes online and starts getting addresses, first off it's link local, it basically needs to find out, is this unique? Can I keep this address? Called the DAD, Duplicate Address Detection Test. In the early days, you had to pass the DAD before you could use the address. The problem was in real-world implementations, it was timing out for logons, for network logons. So now nothing would ever work. The users are coming in, they're trying to get on the network. It doesn't work. What's broken? The network. No, it's never the network. I'm a network guy, right? We're network folks. Never the network. But anyway, they changed the process to say we can do deterministic DAD. Take an address, start using it, do the DAD test. If DAD fails down the road, this could be seconds, could be minutes, then I can't use that address anymore. So I can actually start comms and lose comms. You can do a DOS test. Or not it's always test, right? You can do a DOS attack to basically have a box that sits there and answers for every DAD test. Yep, that's me. Yep, that's me. Yep, that's me. And so now the client OSs act differently depending on how they're doing their address. If they're doing their link local based on the MAC address, they've got nothing else to do. I can't have it because it's already taken. I've got nothing else to gen with. If they're doing that privacy address, which is actually the way most client OSs are doing by default now, they'll generate another number. Woohoo! Yes, I'm here. Yes, I'm here. So says the DOS test. Guess what? Nobody comes on link. The network is down. All right. You want to test these things because the different OSs react different. I've got some screenshots that show this. Some will keep trying. Some will just give it up. They're just done, all right? Every V6 address, link locals, globals, unique locals, all right? Every address has to have a DAD test with it, all right? And if you've got somebody basically answering for every DAD test, yep, that's me, yep, that's me, it's fun. All right, so we need that neighbor solicitation messages and DAD as part of that environment. The duplicate address test, again, a specified MAC prefix and a specified V6 address, back to that double colon address again, all right? So some things you can immediately look for in some of the traces. And any advertisement, neighbor advertisement, is generally in reply to a neighbor solicitation. So the DAD being a neighbor solicitation, anybody out there with Jeff, I know that's not hex, but go with me, all right? And somebody answers, yeah, I'm Jeff. Rats. I'm Bob. Yeah, I'm Bob. You know, I'm Bill. I'm Bill. I'm Alice. I'm Alice. Right? It's easy. Just a quick view of that particular packet. There's a neighbor cache, just like there's an ARP cache. Typically 5 minutes on most client OSs. Time's out. You've got to, reacquire. You've got to do neighbor solicitation to find out if somebody's still there that you'd like to talk to. There's a couple of states in the neighbor cache table. You can kind of read these. Again, all the slides will be available later. This particular chart is something that I put together because things were not working in my early V6 testing like I expected. All right, I got the Slack bit. There's 4 particular bits in a router advertisement that need to be set to support Slack. Slack stands for Stateless Address Autoconfiguration, meaning I am your router, and I'll give you your network prefix. You gen your own host ID. Let's rock. All right, this was part of the first stage of auto-magicness. Well, things that weren't included in the original Slack specs were, no DNS and no domain name. Well, if we fast forward into the later 90s, that doesn't matter that I got a global address. I can't resolve to anything, so I'm still dead in the water. Okay, now we have DHCPv6. DHCPv6 can give me a generated address from a server as well as everything else we're used to with with DHCP, i.e. DNS domain name. All right, so that has different flags configuration, and it's called stateful address autoconfiguration, or pretty much just stateful. All right, you turn off the A flag. The A flag tells a host ID or a host system to use the prefix and generate your host ID. You turn off the A flag, turn on the M flag for managed address, and that says, hey, cool, client, thank you very much. I'm your router, but you know what? I ain't giving you squat. You need to go ask for a DHCPv6 server, see if anybody will answer you. I'm done. I've told you what to do. This is another key thing. Router advertisement, with their flag set, the clients are supposed to do what they are told, when they are told. Think rogue routers. Think misconfigured or specifically badly configured router advertisements. And clients are supposed to do what they're told. All right? Now, there was a hybrid version that said, I really want my router advertisement to give the network prefix, but we got to give out all that other stuff. So I'm going to use some DHCP. And they basically call that stateless DHCP. Still keep the A flag on now, turn off the M flag, but turn on this what's called the O flag for other. All right? I'm your router, here's your network prefix, generate your own host ID, and go ask a DHCP v6 server for DNS, domain name, time server, download server, blah, blah, blah. All right? The manufacturers are really great about telling you all these features and all the flags and what they do. What their docs don't tell you is, what bits do you need on and off? All right? And that was where my dilemma came into. Oh, cool, I want to test DHCP v6, so I turned on the M flag. I didn't turn off the A flag. What did that yield me? It yielded me the router gave me my network prefix, and I used my host ID. There's my first GUA. All right? The M flag was on, so I go, hey, any DHCP v6 servers out there? It's called a solicit message. And DHCP answered, and I said, can I have an address? And he said, sure, here's an address. There's my second GUA in the same network prefix. We don't have that operational behavior in v4. You cannot, on any v4-enabled operating system, have the same network prefix and multiple host IDs. You can have multiple networks. We basically call that multi-netting or secondary nets or whatever, right? But you can't do 10.1.1.1, 10.1.1.2, 10.1.1.3 on anything. All right? I can do 10.1.1.1, 10.1.2.1, 10.1.3.1, think it all /24s, all right? So now I've got two GUA addresses, the one that the router helped me get and the one that the DHCP v6 server gave me. Which one of those two am I going to use? It's a toss-up, all right? And most of the time, I won't leave it that way, most of my experience has been it will use the one from that it got the network ID from the router. It will prefer that one over the one it got the DHCP, which was also not my expected behavior, all right? Oh, and wait a minute. I may also have, with the Slack version, if I'm configured to not use the MAC prefix, but instead use the random number generator, now I've got two GUAs, the temporary and the other one, and a DHCP, all right? Now it's going to use the temporary because the temporary is the most preferred over all the other ones. Oh, and you could statically assign on a device and it still get router advertisements with the A flag and the M flags on. Now I'm up to 4 GUA addresses in the same network. This is going to blow your mind. And basically, the bottom end response should be, that is not the way I really want things. I kind of only want one or two maximum GUAs from one process. All right. So one, you need to set the flags accordingly, and two, make sure that you're getting the expected operation. When you play with that. So this little chart kind of helps where some things come. Now they've also updated the Slack standard to include a DNS entry as well as a domain name called RDDNS. Is kind of the newer version. However, most client operating systems are not adhering to that yet. Windows 10, starting with 1803, just started listening to those Slack flags. All right? Everything else doesn't and probably won't in a Windows world. Linuxes are starting to come in to use it. Android doesn't even do DHCP v6 at all. All right? There's all kinds of little permutations. This translates to, if you're going to light up v6, you need to know what v6 will do on every single operating system, period. And don't just say, well, I've got Windows 10 or Windows 8.1 or Windows 7 and Service Pack X. Oh, in Windows 7, to really make v6 work well, you needed Service Pack 1 and an additional v6 Service Pack at a minimum. All right, everything from there up does a fairly decent job, but again, we're seeing different behavioral changes in v6. Microsoft broke DHCP v6 in Windows 10 about 2 years ago, enough that it affected their own campus greatly. They kind of had to stop v6 on some subnets for a while because they updated Windows 10. Well, of course, now with Windows 10, it's all automatically updated. Thank you very little, right? And it messed them up. Oh, it made as much news as everybody else that was griping about it. Like literally, things were working fine Tuesday, and Wednesday they're not, right? With the Tuesday night update or whatever it is, Tuesday morning, whatever the update is. It was like next day. Everybody's tweeting about it. In V6, real quick, DHCP has a similar process like DORA in V4 called SAR. If I'm told to ask for a DHCP v6 server, I send a solicit. Anybody there that's a DHCP v6, whether it's on net or off net, we have DHCP v6 relay for our routers to get me to an off net v6 DHCP v6 server. So they'll reply back with "here I am," and I send a request. They give me an address reply. All right. So SAR versus DORA, same basic functionality. So now we talked a little bit about some of the security bits. If you haven't already figured some of these things out, the wheels should have been spinning. Oh my goodness. The problem is everybody thinks it's like, oh, this is horrible. Most of the attack vectors are already existing in V4. It's just how many years ago did we stop that, right? How many have implemented things like DHCP spoofing and ARP spoofing on networks? They've turned on the trusted port for DHCP packets. Right? So if somebody in accounting, who I always pick on, plugs in a rogue AP that's also servicing DHCP addresses, and now everybody's getting 192.168 instead of the 10 dots and going nowhere. We have the same thing in V6, so we have to do all the same things again, all the same first hop security protection mechanisms. All right? There are tools, and that's what we're going to talk a little bit about today for this, security assessment, but they're hacking tools. All right? Right now, you're testing this as a security tool. Now you're testing about how I can be attacked and making sure I've got my attack vectors blocked. It's an attacking tool. It's the same tool, right? Doesn't matter. So some of these things go on. Some of these things you'll see here and some indications of what goes on. Again, we cannot block IPv6 traffic, which would block a lot of the attacks because it's integral to the operation. It's not quite the same in a V4 world. It's integral in a V6 world. We've got to have it. The thing, kind of this third bullet down in here, all right, with these RAs coming through, if a V6 network is rocking along okay, and then there becomes a reported problem sporadically, either on a subnet or in a bunch of V6 subnets of, well, it's not working. Oh, wait, it's back. Oh, no, it's down again. Right, and these are the users calling in, and the network's down, and we do a little bit of investigation, but not everybody on that network is down, and there are other people still working. The most typical thing is there's a rogue router feeding RAs that are doing bad stuff, and these clients are doing what they are told to do, which is do an address. So if you're rocking along in a DHCP v6 enabled world with your M flag on, A flag off router advertisements, and the rogue router comes online with A flag on, M flag off, well, these folks are getting a different network prefix, perhaps, all right? And therefore, that's why they're not working. But they'll do either another router solicitation or their router will send out a router advertisement. Oh, look, A flag off, M flag on, time to readdress myself. Da-da-da, da-da-da, da-da-da. And different clients will react to those RAs differently, different client OSs. Some will keep what they know and add the new. Some will drop what they know and use the new. Some will keep the old till the timer expires and then use new. Some will keep, it's different for every operating system, different brand, version, etc. So there's some number of different things we can do. Or I can also have the rogue router that does an A flag setting and basically directs you to me, and I can be a man in the middle, right? The network may still operate just fine, but now I've got all the traffic. I become, because there are preferences in the router configuration in the RAs to say trust me more. And if there's two number ones, right, it's just going to basically flop back and forth. So a number of different things that we can start seeing and potential maybe threats. But again, it's truly nothing new. We just have a couple of different flavors of it. This router advertisement is really new. All right. We always knew the routers were important. They're really, really, really important now. And I've got some fun things to talk about. So the most common attacks are some that what we refer to as the neighbor discovery attack. I kind of spent a minute on the DAD. Router advertisement attacks, there's a couple of things we can do in there. I can just flood the network with RAs. All right, I can pop those things out every second, and that's just to make the clients wig, right? Especially if I give them, I would call it misconfigured from the production type of configuration. I can do DHCPV6 spoofing, which basically says, yeah, I'm your server. Can I have an address? No, they'll have it left. Sorry. And then you think, wait a minute, 1/64, that means my address pool is how many bits capable? 64 bits, right? And I'll proffer this to you. If you go to a V6 enabling, are you going to want it to be easy? Like if your router is now .1, aren't you probably going to do : :1 in V6 because you know? Or your router's .254 in V4, you're going to do : :254. Your address pool in V4 is like 50 to 200, so you're probably going to do the same range in V6. I don't want 64 bits of all this stuff. All I want to do is have 5, 6, and 7th hextets be all zeros. I'm going to play with the last hextet, and I'm going to set a range from 50 to 200. Because that's my V4 world. But you have to remember that 50 to 200 also includes hex, so it's bigger than the V4 world. But it's still those little bitty numbers, right? A lot of people, they're trying to make their life easy, right? And this translates to comma, and that's what the bad guys expect. Because now I don't have to search the first 48 bits of a host ID. I'm going to go search down on the last hextet. And I'm going to do easy searches like : :1 to : :254. I'm going to search on hex words because I'm going to go get a hex database, hex word database. All right. I have a link to one on that GitHub README page. All right. Just one. I found a bunch. You know, if you do a search for it. So there's a number of things that I can do in here, and it's going to make life easy. I started talking about this. If I find the first 64 bits of a network prefix, there's no more scanning the first 64 bits. I've only gone down to the last 64. I already talked about one particular way. The other things that folks are doing to be cute is they're taking the 4 digits of a V4 address and they're putting it in. 10 would be in hextet 5. And 1, and 1, and 1. So they're embedding their V4 address in a V6 address. It's with colons instead of dots, and there actually was a V6 V4 address that's been deprecated, so you don't see dots in a V6 address. Or they'll be cute. We'll convert our 10.1.1 into hex, right? Oh, wait, and I can drop the leading zeros. Or I'll just do it this way. Again, my attack vector is now this big in that mode of thinking. And I'm going to do that. That's what I'm going to start searching on as a bad guy, attacking. Because everybody wants to make their life easy because there's not enough time to do the regular job to begin with. That's throw in a stupid new protocol, right? So, yeah, we're going to look for this kind of stuff. I'm going to look for things like in the middle of 6 and 7 hextets for FFFE, right? I'm going to scan that really quick, and I'm going to find the addresses. And most likely, the addresses that have FFFE are routers and firewalls, because that's their default use of getting a host ID for linked locals. Most of the client-server operating systems at default use the privacy version, the random number generation. You can change that behavior if you want. Most of the router and firewall code only use the MAC address as the foundation, or you might be able to configure your link local. Like, who cares that it's FE80 : 64 bits based on the MAC address? I'll just do FE80 : 1, because my router interface is .1. It is now : 1 in the GUI address. I'll make it in the same thing in the link local. Not all operating systems allow for that, i.e. routers and firewalls. So there's a lot of stuff about this that we want to make it easy to use, and from an attack vector, yeah, they love that. Thank you very much, right? I'm going to, I can set up a few little scripts to do some of this stuff, and I can scan that few address spaces quick, right? Basically, maybe a little bit longer than a V4/24 scan, but not that much longer, not in the relative terms. And if I don't find anything this way, I'm just going to move on, right? There's some other things I might could do. Can I get onto some host? I have a fun demo that I do or I come in through the public internet on a v4 address, I find a server, it turns out to be a Windows server that RDP is open. Is this believable? Even still in 2019, all right? Or some other exploit, still believable, all right? Once I land on that machine, I do a quick little IP config, find out that v6 is not enabled, yet there is still my linked local address, and the next thing I do is I drop on VirtualBox, I bring in a virtual router, I bring in Kali Linux and a couple other Linux hosts, and I am scanning your network on v6, and you don't even know it, because the security team has what v6 enabled? Nothing, because they're not watching v6 because we're not running v6. But they are, and they don't know it. So now I can find out everything about this local subnet I'm on just with linked local addresses and a couple of tools. Wireshark's another tool I put under my VMs, right? And because most servers are remote managed, nobody's watching a screen seeing what I'm doing, right? Woo-hoo. It's amazing what the security folks and networking folks, they just kind of go, oh no. And that's a good thing, right? That's what we should see, because it's really, really easy. Wireshark colors, the only reason I'm going to bring this up is router advertisements in my Wireshark are red. Router solicitations are pink. I expect those packets, so if I'm looking through a live trace or through a trace file, I just want to see them. I'm not necessarily focused on them, but I just want to know that they're happening, all right, on a periodic basis. Wireshark's color rules by default has ICMP and ICMP-v6 traffic the same color, light blue. Well, I don't like that, so I put a ICMP-v6 filter a little bit higher and made it kind of a really horrible-looking yellow-green. But again, I know that's ICMP-v6 based traffic. Yes, I need to go deeper into it because there's a lot of ICMP-v6, but it's just ways I can very quickly see the traffic. The next thing I'm probably going to do is put a display filter up in there for just IPv6 and get rid of all that IPv4 nonsense. Right? Get rid of all that layer 2 nonsense, spanning tree, link layer discovery, Cisco discovery, blah, blah. You know, all those things that are happening down there. I don't care about that right now. We'll look at v6 stuff. It's a v6 world. So you can play with that. There are 3 primary display filter families in Wireshark: IPv6, ICMP-v6, DHCP-v6. Very quickly, you can start isolating down and looking at your v6 traffic, and then you can start to build more filters to look at all kinds of different things. Who remembers what these two are? ICMP-v6 types 133 and 134. What are those? Quick. Which kind of advertisements? Are you sure? Are you willing to bank your job on this? Come on, say yes, I'm sure. All right, good answer. They are. Those are the routers. Which one's which? That's okay. I don't even always remember it, right? I don't have to remember. I got something that'll tell me. 34 is router advertisement. 33 is router solicitation. And the kind of the mode that I sometimes remember too is the solicitations before the advertisement in the pairs. So 33 is the router solicitation. And remember, router runs before the neighbor. 35 and 36 are the neighbor pairs. All right? It's those little things that help over time, right? We'll get there. So anyway, some of these things are going up here. I'm going to point this particular filter out. DHCP-v6 and a router advertisement. Why might you want to see that kind of traffic together? If the router advertisement has the A flag on, there'll be no DHCP solicit messages. If it has an M flag on, there'll be router or an O flag. It'll have router solicitation messages. So if my world is A flag off, M flag on, then I expect to see fairly soon after router advertisements some DHCP solicits. If I don't, ooh, that's not funny. Because client OSs also can allow to forget what the router advertisement says, just do what you're told. But the default is to do what the router tells you to do, all right? So if I'm experiencing the attack and the reported result or the reported operations on my nets are, it's intermittent, all right? First thing I'm going to do is fire up Wireshark on a client segment. I'm going to probably set this filter to look for router advertisements and DHCP-v6 traffic. If I see router advertisements on a periodic basis, no DHCP solicits right after my RAs, and then the next thing I'm going to do is look at the source address of that RA, and hopefully I'll be able to tell that's not my router. Because if my router is sitting with a source address of FE80::1, and I get another one that's FE80::64 bits, or anything else other than : 1, that's my rogue router. That's where I'm probably not seeing DHCP solicits right away. I'm seeing them after my RAs, but not after this other RA. Who put another router on the network? All right? So there's some of the really, really quick things that we can do in looking at some of the traffic. That's just a quick one there. So we get that. Profiles, you'll probably start getting to the mode if you're working with profiles now to build you at least one V6 profile, because you may have certain things in settings and you may have a few. I've got a few in here that I do a couple of different things with, so I can bounce between them really, really quick. Packet comments. So one of my favorite things to say is, how many have traces of the good days of the current network? When things are working, when the application's fine, when nobody's complaining. Yeah, so how do you troubleshoot that network when something's bad, when you don't know what it should look like when it's good? And I kind of say that sarcastically, all right? Because we're all there. We've been there, all right? So in your V6 testing and trying to kind of nail it down as to how things operate, start making comments in your traces, in your testing, and then when you get ready to do your pre-production test and then your production rollout, get those traces, make some comments. Yeah, the RAs are happening, so frequency, people are responding. Make those comments within your traces so that you kind of have an idea. All right, so let's talk a little bit about the hacking. First off, you do not run these tools without permission on your network. All right, this is my get out of jail free card. If you do it, I did not tell you to. All right, these tools can wreak havoc like any other hacking tool that you use as a security assessment function. It can wreak havoc. All right, so we have to say that. There's two main toolkits: the Hacker's Choice IPv6 and the SI6 Networks IPv6 toolkit. These are the two primary kits. Like so many other folks that have done open source projects, these guys did this for themselves. I need to figure out what happens on the network when things aren't correctly done. All right? And that's why I always kind of preface these as the security assessment tools. There's a few other tools. Nmap has come a long way in enabling V6 components. It's typically Nmap something, either something tool -6 or Nmap space -6 something tool. All right, so a large number of their tools. If you just try to do a generic scan on a V6 network, it's not going to come back in our lifetime, some of our lifetimes, right? Don't waste your time. Anytime you're doing just a generic scan of an address block and you're looking for addresses, you got to do a very, very targeted, a very, very finite scan, all right? There's a couple of the other tools that basically do packet crafting, Scapy and Chiron, and can do just those kind of things, right? So there's probably more out there. These are the two primary tools I'm going to be talking about. But I can also just use a router that maybe also supports DHCP-v6 services to do all the same kind of work that these tools are, all right? And I will show a couple examples of tools, these tools, and or a little VIOS router. Okay, so like I say, you're not going to do these now, but a few examples of some of these things you can do when you build up a little system. This particular one is sending out router advertisements on this interface under this prefix with this basic lifetime timer, and it will use the half of that for the preferred timer. And I'm also sending out with the -big D my DNS for those people that are listening now to the RDDNS RA. A capable RA. You run it and then stop and then go look and see what you see, all right? And these are the kind of some of the things that you might see. So before I get all the way to this, a few things I want to show. And I probably talked longer than I wanted to, but hopefully this is okay. All right, so the first thing is I've got my hacker network, right? And I've got Wireshark basically running. And the first thing I want to do is I'm going to fire up a server. So a few of these things will take a minute. I should have fired them up a little bit quicker. All right, I'm just going to fire up a Windows server. It's got DHCP, DHCP-v6, DNS, web services, a basic Windows server, all right, giving me all kinds of things out there and for its operation. What I want to start seeing from a Wireshark perspective, now that I've got it on that same network, is what traffic do I see? And look at that, all ready, all right? That thing has been on how long? Seconds? All right, first off, let's throw on a V6 filter. Look at the first couple of packets it sees in V6. What packet types are those? Quick. They're DAD test. All right? I do know that. It's a neighbor solicitation. They're double colons. And two things I should probably do. One is that, and two is, let's move this over just a little bit. All right, the neighbor solicitations for a link local and for a global unicast, because they're sourced from : : it's the DAD test. I know this. I expect this. All right? You look down there, what was the next thing that happened? That V6 interface sent out a router solicitation. Are there any routers out there? All right? Then there's some other ICMPv6 traffic. LLMNR is V6's version of on-link DNS resolution. All right? There's another router solicitation. I'm still waiting. Anybody out there? And he's coming online, and he's starting to do some queries, AREC and quad AREC queries, and on and on and on. And he's just sitting out there, and now he should be basically up as a server. Life is good. We go look at his configuration, and I can't spell. And I see that on this particular interface, he's got V6 addresses. He's got a link local. He's got a couple of GUA addresses. All right? And I'm going to tell you a little about this, if I can get this on. He's got a : 2000 and a : 100. I happen to know the : 2000 is the statically configured. But because Windows does have that little box to say use DHCPv6, Windows will go ahead and send out router solicitations, or excuse me, DHCPv6 solicitation messages. And if on that net there's a DHCPv6 server, it will answer and go, here I am. Hey, can I have an address? Well, sure you can. Well, I probably don't want my server to have those two addresses. So I'd want to go into the server OS and turn off the DHCPv6 functionality because it's a static address device. All right? But just so that you see this kind of stuff is important to understand from the verification, validation of what should be on the network versus what might happen on a network. I.e., local DHCPv6 server will answer anybody's local DHCPv6 message. All right? And then we end up kind of knowing that that was not a message that we wanted. So while he's coming up, I'm going to do a few more things here. There we go. We finally get him. So let me show you this real quick. Because we're going to look at this a little bit later as well. Running my DHCP services, and we'll open it up. I only really care about these 6. I have a couple of scopes. And if I were on the right scope, lab base, look at leases, then there is going to be that 100, and it's that server. Now, there's a few more bits of information that you need to know here. A V6 client, how does it know who's its V6 router? A, through router advertisement. B, through DHCP scope definitions. C, statically configured. Now, could it be any one of those 3? Who would say yes? Come on, cough it up. Who would say yes? Because you're thinking in like a V4 world, those are all the valid ways. The answer is no. The only valid way is through router advertisement. There is no field today in DHCPv6 definition for a default gateway. All right? There is no field for it today. There is a big lobby to change that. If a client OS or any OS has a field for a default gateway, thank you, Microsoft, so not the case. You can put one in there. It doesn't matter. It's not going to use it. It's going to use what it's told through the router advertisement. So humbly, I wish they had even put the field in there. What's going to happen in a V6 deployment is the network team's going to get it all up and running. They're going to go to the server team, say, we need you to create some DHCPv6 scopes, and here's the address prefixes, and here's the ranges we would like. And they're going to go, dumb network guy, where's the default gateway? If they've never set it up before. And the network guy's going to go, dumb server guy, you don't need one. I'm in control. Just put in the stuff I've given you, life is good. All right? there's some important bits to know about that, because again, if we look at scope options, all right, and even if I were to go in here and look for options, I'm not going to take all the time to go slow, there is no field to do it because I want to. There's actually lobbying being done for that. So right now, I see I've got multiple addresses on this particular client. One of the things I want to do right now is that because this is all a VM platform, let me bring up this laptop's interface in the VM platform. It happens to be VMnet 9, and just enable it. And say again, please. Just say it one more time. No. It's oh, well, there might be some V6.
It is.
Is there? Is it? Can you get to the outside world on it?
I didn't understand it yesterday, but after this presentation, I'm going to have to go back and check.
Mission accomplished. I'm done. Thank you very much. Now, I haven't even bothered to look, right? There's something about public internet, no protection, security thinking, but that's okay. We're all friends. Nobody's hacking the network. One of the hacking groups in Dallas is they have two mottos, two rules. Don't hack the venue and don't hack each other. Okay, what does that leave? Everything else? But anyway, right? So, I'm not doing anything on the public side, but I hadn't even looked, so that's pretty cool. Thanks. So, VMnet 9 is my interface on my local computer here. So, if I do IP config, got to spell it right again. Why doesn't it know that? Right? And go down. Oh, I went past it. VMnet 9. All right. VMnet 9 has his link local, and he has what's going to turn out to be a DHCP address. Wait a minute. I don't have a DHCP server. Oh, yes, I do, on the same net back here at this server. And if I go over here and look on this server at the leases and do a refresh, there's my new guy. He's at 108. Woohoo! Wait a minute, Jeff. You said I needed a router to make that work. Yeah. I also said Microsoft has that little box. They have it in their protocol, so it can still do a DHCP request, a DHCP solicit. They did, and the server is on link. All right, so he answered, so I've got addresses. So both of these devices have not only their link local, but they have GUAs. All right, so if I go over here to my server and I try to ping that 108 address, so 2001 colon DB8. Oh, by the way, 2001 colon DB8 colon 32 is a reserved address for documentation and lab and examples. So if you're doing anything kind of like what I'm doing, that's a safe address. It's not publicly available. Right? Another one of those, you should protect yourself just in case from the forward-facing side, but it's an internally available. You can use it. Anything after the first 32 bits is fully usable inside an environment. Base, and I'm 100. I'm going to ping 108. I'm going to give you a quick question. You think this will work? Yes? All right. The server sitting at colon 100, the PC right here is on the same network sitting at colon 8. Do you think this is going to work? Come on, yes? By everything you know, you think it's going to work? Come on. Who says no? You say, well, Jeff, why did you even ask the question? That should have been the first clue. That's kind of why I did it, right? It's not going to work. And you're going to go, I don't get it. In V4, this would work, yes? Yep, colon or .100, .108, ping every day. Router, who cares? They'll need a stinking router, right? Oh, in V6, it doesn't matter that we are on the same network. I need to go find out from my router what should I do next. So I have to basically first go to my router to say, hey, router, should I do this on as a local multicast or an off-net multicast? I don't have a router. There's no router to answer. So I cannot ping a local global address without a router. Meaning if my router goes away, all local communications, in addition to, of course, all off-net communications will go. But my locals will too. So if my applications are using GUA addresses on link, on the same layer 2 broadcast domain, and the router goes, they will cease to operate. If I'm using my link local addresses, don't need a router. Don't ever ask for a router. Don't care if there's a router. All right? I can keep working as long as the link locals stay, as long as the network is up. So this will fail. Now here's going to be a fun thing. In Windows, since 7 and the Service Pack 1, you have not had to designate if you want to do V6 or V4 kinds of work. In almost all the Linuxes, if you do a ping command, here I would either do a ping 6, a ping space -6, on and on. There's a few different ways. Router and firewall operating systems at command line, they need to know the difference between ping for V4, because that's the assumed, and ping for V6. Microsoft, I actually can do it either way. I could do a -6. All right, it's not going to matter. But where this does actually matter, and again, now you start thinking about what can I do. Ping IPv6 sandbox.com. All right. Now, if you remember, my server was also sitting at : 2000. I also said it was a Windows server. I also said a while ago I can't ping the GUAs because I didn't have a router to help me. Well, here's how this worked. This, again, becomes part of those almost like the attack vectors. If I go back here and I just look for some DNS traffic, that's not what I wanted. Wait, where'd it go? Oh, okay. Why is my screen not giving me what I want? If somewhere in here, and I've just lost it. This might be it. One little bit. I'm not finding what I want to look for. The bottom line is, in a V4 and V6 enabled interfaces, a V4 address will try to do DNS resolution with both A and quad A requests. A V6 interface will do a quad A and an AREC request. So I've got two protocols, each asking two questions. Can you resolve www.ipv6sandbox.com any possible way, and what addresses can I get back? So what virtually happened here is I got my resolution through V4 with a quad A record. I didn't have to ask the router how to do it, so I can ping. I didn't have to go to the router because I got something ahead of time. That's another little bit of a thing. Again, 7, 8-ish years ago, there was an RFC that was nicknamed Happy Eyeballs. And part of the problem was, since the system preferred V6 over V4, it would only do V6 queries. And then, if you didn't get anything, it would fall back to V4. And that was taking too long. The network is slow. I can't get to what I want to get to. Oh, wait, there it came up. All right? So now we do multiple questions with multiple protocols. And however I can get some information, I'll use it to my advantage. And because I just said ping www, right? IPv6sandbox.com and not ping 4, then that's how that came through. So where did I ping that? I pinged that over here, didn't I? I may have messed up on my ping. I may have. If I redo this to -4, then I find out there's my V4 address. This will work for now. Okay, so the client, we don't have a router. I've got GUI addresses. That's how I got them because that's Microsoft Windows. If I come over here and fire up a Linux client, let him go. Let's go back to watching Wireshark while this guy comes online. And we'll give this another minute. I want to run one of my tools real fast, at least one. Basically what's going to happen, Linux is going to come up, and because Linux doesn't have the box for go ahead and do a DHCP request, Linux does what it's told, right? It's architected to basically do what it's told. And so as it starts to come up, it's going to generate, oh, V6 interface is up, okay, let's do a DAD test for my link local address I want to try to do, and that's all it's going to do. It's not going to also send out a DHCP request because it hasn't been told to yet, because I don't have a router on my subnet to do any of that work. And there's its DAD tests, Here's its router solicitation. Never heard an answer back. If I come over here to the Linux client and look at him right quick, log in, we will see as he comes up that he'll have an address and life will be good. So a tidbit about V6 operations. If you want to do V6 work with link local, i.e. ping the link local addresses or have applications, the added component that you have to know is not only the link local address, but you have to know where that address lives, what interface ID, the physical interface ID that it lives on. Kind of like in Linux, ETH0, ETH1, right? ENS33, ENS34. Windows, it's the Ethernet, it's the wireless, it's the VMnet 9, okay? Those all have an assigned number, an interface number to them, a hardware interface number, sorry. And you have to actually put that in your commands to use a link local address. The reason is all the interfaces in a device can have the same link local address because they're only link local. They're only on that layer 2 domain. So a switch with multiple VLANs and different V6 subnets can have the same FE80::1 or routers, all right? Or all my interfaces on my client because it's not routable across V6 subnets, all right? So that's why you have to basically say which interface do you want to execute this link local command on, this link local access on. So it's another little tidbit of information that I can conv with link local just like I could the IP address. And even if it's the only interface in that machine, I still have to say which interface to use. It's just basically the way the protocol is written. So if I look at this, do an ifconfig, and if I make this a little bit bigger here, we'll see this guy. I happen to know that for me, this is interface 34, so I'm going to say ENS34. And right now, all I see over on this guy is a link local address. I don't see anything else because there's no router, and Linuxes by default don't ask or send a DHCPv6 solicit message. So if I'm trying to attack a subnet and I want to send RAs with the M flag on, and maybe that's not the operation of the production environment, I turn on the M flag, I'm going to get Windows computers to respond to me. Actually, I don't even have to turn on a router advertisement. I can just fire up a DHCPv6 server on a subnet, and Windows computers will go, it's time to ask for an address. It's already got a static. It's already got them from other things, but as soon as it maybe in its own production world gets an RA with the M flag on, they're sending out a solicit message. It's an all points multicast, link local, or on link multicast. And every DHCPv6 server that can answer will, the local one and the one that's got the router or DHCPv6 relay turned on the real router. So multiple DHCP servers are going to say, here I am. They're going to advertise back. What's the client going to do? Hang on half a sec. What's the client going to do when it hears 2 responses from 2 DHCPv6 servers? Which one is it going to ask for an address first? All right. It can be random. Now, most DHCPv6 servers also allow a priority setting. So you would want to set your DHCPv6 server with the highest priority. Well, I'm a bad guy. What of course I'm going to do on my DHCPv6 server, I'm going to set high priority. So we're back to that. All right. It is mostly the first one that replies is who I'm going to ask. And probably the one on link is going to get there half a second quicker than the one that's off link, right? Just because there's that much delay. It's not guaranteed. So that's where the next thing you know, I can give clients addresses from my rogue DHCPv6 server without a router on link. It doesn't work for Linux nets. It works really good for Windows. Now, if you've got a mixed world, that's even more interesting because you'll be able to kind of discover, wait a minute, some of these folks know about each other, but I'm not knowing about them because I got a rogue DHCPv6 server online. Ah, that means I've got some Windows and some other stuff, basically anything else other than Windows. It's not Android because Android doesn't support DHCPv6. I know this, all right? So some of these testing modes and results can tell you a lot without really a lot of information. I don't need all the addresses of stuff on a subnet. Sometimes I just like to know what subnet I'm on. If it's a subnet with printers, I'm probably going to stick around because printers will give me another attack vector to do other things, jump from there, right? Possibly easier than computers. If I find out X, I can do other things. So far there's no router. I'm going to try to do this. I'm going to try to do one more thing. I'm going to fire up a router. This is a legitimate router on my little network here. And I've got everything running. Yeah. So what should happen is that this guy should come online. When his V6 interface enables, he should send out 3 router advertisements, bang, bang, bang. Any of my clients that hear this, and they should all be listening, and how many clients do I have on this net now? 3. The 3 that I've talked about. There's the Wireshark computer has all the protocols turned off, all right, so he shouldn't be answering. But I've got my client on interface in that network. I've got the server, and I've got the Linux client, all right? So if you saw, did any red go flying by a while ago when it started, when activity kicked in, all right? Did you happen to notice any DHCP solicit messages go across? Right? If you're watching, I'm not saying that you had to, just kind of seeing what goes on. In fact, let me do this. Let's go to RAs. All right, so I've had 3 RAs. Let's go to the first RA and back to V6 traffic. All right. So router advertisement went out. I start to see some DHCP V6 traffic. When you see confirm and replies, this is more typically a Windows computer because they write their V6 address to soft registry. So since this computer has talked to this DHCP v6 server before, it has in soft registry its last known DHCP v6 address, basically saying, can I have it again? That's the confirm message. He didn't actually do a solicit. He knows there's one out there because the router advertisement said, hey, there's a v6 server supposed to be out there because I told you there's to go ask for one. And Windows has it said, well, if I've already got an address and I've talked to a server before, let's just see if I can keep it. That's the confirm message. So I didn't see the solicit, advertise, request, reply. I see basically a confirm and a reply. That's Windows. All right. Now there's a tangent difference to DHCP v6 operation with that platform of OS. If we look a little bit further down, we should see, and we do, a solicit and a reply. That solicit message came from the Linux box. All right, quickly how I know that, if I look at the linked local address, A105, we pop over to Linux real quick, and look in here, there's A105 in the linked local, so that was the Linux box. Doesn't matter that he'd ever talked to DHCP v6 server before. He doesn't write anything to registry. These computers were downed, okay? Mine in particular wasn't, but the Linux box is down. I've got another Windows machine I could bring on, but I don't have enough time. If we pop over to the server computer, we go look in DHCP v6, we refresh that, we see that there's an address to 109. We pop over to the Linux box and rerun our ifconfig, and we see, sure enough, now he's got a global unicast address at 109. All right? And Wireshark showed us all this stuff happening, plus all the other DAD tests that were going on, et cetera, et cetera. All right? I didn't do anything else but turn on the router. The clients did what they were told to do. The router advertisement gave them their settings, and they're like, thank you very much. I will act on those. If I come back over here, do a quick sort on router advertisements, I'll look at one of these guys, bring this up a little bit, and I'll look at the particular flags. Here is the M flag that's on. All right, if you can see that. And way down here is the prefix information, and here is my network prefix, and here are the flags under here. The A flag is turned off. Now there's another flag. I did not really mention it other than it was on the chart, and it's called the L flag. It's the on-link flag. Generically, this says, I am a router on this link, you can use me. Unfortunately, the RFC says you don't have to use it if you don't want to. Windows kind of doesn't care what the state of the L flag is. Pardon me. If it hears a router, the client sees it, it'll use it for a router. Apple OS, if it sees the L flag off, will not use it as a router. And that's because the RFC does not explicitly say you must. It says you can. It's optional, all right? And like many of our standards, right, they're ambiguous. And you will want to know these things. I turned off the L flag, and my Windows clients were happy, and my Macs stopped going off net. That was not exactly the behavior I expected from Windows. I turned off the L flag. Okay, back, but wait, Apple. So who's right, who's wrong, generically, right? Go back and read the standard. I was kind of thinking that Microsoft was at fault. Go back and read the standard. Oh, wait a minute, this doesn't look good. Oh, it doesn't say you must. You know, thou shalt. Doesn't give all those kind of words. It basically says you can, you may, which means it's up to the developers. So at this point in time, neither one is wrong. They took it upon themselves. So it kind of becomes one of those things, well, the L flag doesn't help me out much because not everybody's adhering to that. It's either my router or it's not a router, all right? Part of these things are what flags you can play with in your security testing, you know, in your functionality testing. I am really close to out of time, so I need to do this. Remember I said a while ago, you want to kind of look at router advertisements and then see if you see any DHCP-v6 traffic right away, all right? So far, I saw a bunch of DHCP traffic. Then a little bit later, I see a router advertisement, and that was their confirm replies. There's a solicit. See where that's really handy? Looking at two types of traffic, but I've narrowed my focus down to, I'm just looking at addressing functionality here, right? A router advertisement came, the clients reacted as soon as they got it. Nothing else done, nothing else touched, no other config, out of the cardboard box, all right? All I had to build up was what my router configuration looked like. And the other bit, if I look in here, is I've got my router advertisements. Where is the timing, preferred lifetime, router life, prefix, where is it? There's, we may not even see it in the config. I've got my router advertisements down to like, here's some within 16 milliseconds apart, 140, or 16 seconds, 140 seconds. I've got a fairly narrow window. I don't have 6 to 10 minutes. It's a lab. I'm not going to wait 6 minutes minimum, right? I got these things tweaked down to not much at all. That would not be a regular production world. I don't need that extra overhead traffic. A lot of folks will say, well, I've just looked at V6 on my network. I'm not running it. I got all this V6 traffic. There's a bunch of traffic. Yeah, but they're all small packets, all right? But they're there. If you don't believe me, go home on a public, on one of the, not public, but on a subnet and just fire up Wireshark. Filter on V6 and just look at the V6 traffic and go, oh, wow, that's pretty interesting. All right, I want to do one attack. I want to do one attack. I'm not going to get to do all of them. Has this helped so far? All right, you kind of see some of the ways that it can be attacked, even without the showing and the talking. So I need to fire up that. I'm going to do it this way. I'm going to fire up a VIOS attacker. Such interesting names, right? The attacker is a rogue. He's got differently configured RAs than what my production world should have. So what I'm going to do is bring this up and let him come up, and let's just watch the traffic kind of go through right now. We've already got some things happening. We got some queries going on, DNS queries. 109, you might remember, is the Linux box. 108 was my Windows box. Look at it. I got some addresses starting to come up here doing the DAD test. I've got a router advertisement. You know, we should start to see after this router advertisement some possible other things going on. So far, everything looks pretty good, which means probably my router's not fully up and running. Now we're starting to see, and if you can focus in real quick, look at the 4th hextet of this other one, bad. Well, that's probably a pretty good indication that's not the right router, right? I see some other traffic. Now, the call comes in, well, the network's acting weird. It's working, it's not working. Well, is it on a specific time? No, it's working, it's not working, and the network's bad. The network's got a problem. All right, Very quickly, just come up and do a search for V6 router advertisements. And I apologize, you can't see it as well, but I can basically say FE80:20C, 20C, 29FF, FE, and then 17s and 96. I've got 2 routers. Which one's good, which one's bad? All right? In my world, my router advertisement should have the A flag off and the M flag on. That's my production world. So I've got a profile in my Wireshark that I have configured, if I could get to it. That's not the one. All right. For router advertisements columns, A flag and M flag. All right. So I added 2 columns in so that I could very quickly look and see, well, all these router advertisements, what's set? All right. I've got some where the M flag is set on, some that are not set. The A is off and the A is on. All right, 2 routers. My router should be the one with the M on and the A off. So that means that I've got a rogue router. He's got his flags differently set. Let's go look at some clients and see if anything looks different on any of our clients. Let me move this window a little bit. Boop, bang, 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 bang. VMnet 9. Look at this guy. All right, this is on my PC, plugged into that same network. He's got some addresses here. He still has a lab base, but now he's got a 200 bad. They're different networks. This is one, not a, well, it is a problem, but it's not a, unto itself, it's not a bad thing. It's very legit. Now, what was my rule of thumb of all the GUA addresses, which one am I going to use for comms? Temporary. The temporary is now on the bad network. So I'm effectively going to try to use this IP address, this IPv6 address, to do things. So it's going to go to the bad guy router. Now the bad guy router may still go ahead and forward things as appropriate, right? But he's now a man in the middle because he's not my router. Yep, my regular router's a man in the middle, but it's okay, right? He's not doing anything bad from that perspective. All this guy may be doing is just filtering the traffic. Thank you very much. I got all your off-net stuff. Woohoo! Right? We'll deal with all that stuff later. Look at my default gateway. I've got 2 of them. All right? One's the bad guy, one's the good guy. And on and on and on. All right? If I go look at my my Linux machine real quick and do a similar command, right? Bring it up. Now I see this guy. He has his 2001 DB8 200 bad. He does not have still a lab base. All right? Same 2 routers, same operation of the configs of each. You know, they're different. But the client OSs react differently. Windows said, oh, I got one through DHCPv6. That's a keeper. Oh, I also got one because of the A flag on this other guy I gave you. Oh, that's a keeper. All right? Very quickly, you could spot that kind of stuff. The attack was easy. Whether I'm using one of the tools, and that I'm out of time. If I use one of the tools, I can implement the same thing. There's some of that stuff in these files. All right. So if you use the hacker choice tools, we've got that. If I use the hacker's choice for DHCP attacks, most of these tools have like 36 pieces in them. Not always, I would say, very explicitly well documented. It takes a while sometimes to figure it all out. There's some samples that you can search around for and find, but still we can do a few things, and this is in there that you can play with on your own. We've got the DOS attack. This is basically the one that answers to every DAD test to say, yes, that's me. Yes, that's me. And it builds up a little list that says, yep, I just spoofed for this one. Yep, just spoofed for that one. Woohoo, we're rocking along, we're rocking along. And the poor clients out go, I just want an address, please. Give me an address. All right? And in most of these, I give you some outputs as well, so you can kind of refer to it and see what it looks like after running these, you know, a Windows view and an Ubuntu view. This is fun. They actually tell you, Dad failed. Right? It was tentative because it hadn't, oh, dad failed, and you go back and look on your DOS attacker, that's me, yes, that's me, I answered for him, oh, there's another one of me, there's another one, all right? So, I'm done. I don't want to cut into your lunch. I apologize, I didn't get more into the tools, but hopefully you can kind of see, you don't have to have just tools, all right? You can use a router hanging off the side over here. If it supports V6, you can use it to do the same job, all right? You can configure Windows servers to be a V6 router. It's clunky, but it works. Tons of Linux utilities can be routers. You don't have to have these attacking tools. You don't have to have router code, all right? There's different ways of doing it. But part of it is just to understand what can happen even in the production world, and then understand what could happen if bad things come on the network. Right? Not only for how to protect against it, but how to scan it, or how to recon, any kind of recon. If you got questions, I'll be around, all right? I'm here the whole time for SharkFest. I hope it helps. Thanks very much again for coming in. Please do the surveys for this day and tomorrow, and for all the little classes you're coming into. We appreciate that as well. And thanks. Done.